example 3. So now I'm taking the derivative of the function u of x, and when I look at u of x, I see an x cubed and an x squared, and because there is no plus or minus in between the terms that contain both of the x's, I'll be using the product rule. So I'm going to identify the f part of the function as everything before the exponential piece. So f is going to equal 9x cubed, and let's go ahead and take the derivative of that now to be 27x squared. The rest of the question is going to be my g function, which is 4 to the x squared plus 1 power. And we need to take the derivative of that, but don't forget it's exponential. So we copy the question, 4x squared plus 1, take the natural log of the base, which is 4, right? Only 4 is the base. Now the binomial x squared plus 1, the exponent, we take the derivative of that to be 2x. And let's see, natural log of 4 does not go away, but we do tend to rewrite the problem as 2x ln of 4, and then 4 to the x squared plus 1. If you don't write it that way, you would be okay. So I'm ready to take the derivative using the product rule. The product rule says first, take f prime, which we know is our 27x squared. So the derivative is 27x squared. Now take g in its original format, which is just the exponential 4x squared plus 1. The formula always has a plus next. F in its original form, so 9x cubed. And now g prime, where I'm going to use the simplified g prime of 2x ln of 4 times 4 to the x squared plus 1. Now our next step, remember, is to factor. You could multiply the 9 and the 2 on the right side of the plus sign to get 14, but if you're really focused on just the numeric leads, remember that the 4s are bases or part of a natural log, so there's not something you can factor from that piece. So looking at a 27 on the left and a 9 and a 2 on the right, the only thing I can do is factor out a 9. And you know what? It's not too hard to look at the x's also. Remember, if you have an x squared and an x cubed, you could factor out the smaller of the options. So what we're going to do is first factor out a 9x squared. I can take a 9 from the 27 and an x squared from that piece, and a 9 and an x squared. So I'm going to write 9x squared out front. When I factor it from the 27, I'll just have a 3. And of course, when I take the x squared from an x squared, it's gone. So we just have the 3. Keep in mind, we haven't touched the next term. So we'll go ahead and put the 4 to the x squared plus 1 power. Copy our plus sign. And the 9 will factor out all of the 9. But from the x cubed, we're only taking 2. We're only factoring x squared out of that. So we'll start with just an x. And then the entire rest of the problem gets copied over. And we even had more x's we could have factored on the right side, but we'd already kind of maxed ourselves out. So now we want to notice that there is an exponential term on both sides of the plus sign. So second, we're going to factor the 4x squared plus 1 out. If you could have factored everything out at once, that's great. I just find people get very confused with this problem, and it's better to go a little bit slower. So I had already factored a 9x squared out. I'm now going to increase that by a 4x squared plus 1 and see what's left. So of everything on the right side of the plus sign, if I'm factoring the exponential out, I'm only left with that 3. Then I have the plus. On the right side, I've got a lot going on, so we might actually want to multiply the x times 2x squared, but they're not factoring out, so we can just write this as 2x squared. The ln of 4 is not factoring out, but we did take all of the exponential term, so we're done. We have our answer.